Alright, number 3. Third problem. A triangular channel with most efficient proportion discharges water at the rate of 1 cubic meter per second, assuming n equals 0.018 and slope 0.0021. Calculate the normal depth of flow in meters. So I've drawn it already. So in your exams, wala to or quizzes, wala yan. So you have to draw it. Okay. So we're to solve for the depth of flow if we are going to use the most efficient triangular section. So the most efficient triangular section has a central angle that is 90 degrees. If that is 90 degrees, then the side slopes would be 1, 1, and then the hypotenuse here would be square root of 2. So if this is x, see by ratio and proportion, we know that, so since 1 naman yan, 1 vertical, 1 horizontal, if d ito, that means x is also equal to d. And the base here of a triangle is equal to 2d. So from our equation of discharge using Manning's formula, Q is equal to A over N, R raised to 2/3, S raised to 1/2. So, saan kukunin yung D dito, ano? Yung D, how do we solve for D? Given yung discharge natin, how do you solve for D? So, that will be coming from the items here in the equation, area. So, we need to solve for area in terms of D, and we also need to solve for R in terms of D. No. Since given naman yung equation ay yung discharge natin, then we can solve for D if we can express our A and R in terms of D. So that's our goal. So we know that the area is equal to 1/2 B, the area of the triangle. So the area of flow here is the area of the triangle. And X is equal to D. I have already explained that. And B, ito, yung pala B pala yung nakalagay doon, that is 2D. 2D. So, the area then, in terms of D, is equivalent to 1/2 times 2D times D. Okay, so the area is equal to D squared. That's the area of the section. And then we also solve for the wetted perimeter in terms of D. So we need to express y. We know that the wetted perimeter is too wide. This is the slant height of the triangle, or that's the sides, the length of the sides of the triangle. This wide is also y. So we need to express y in terms of the depth. And we do that by ratio and proportion. So y over d equals square root of 2 ito over 1. So y now is equal to, ay, nakikita pa ba? Sorry, it's a video. Just fix it. So y is equal to d square root of 2. So y is equal to d square root of 2, so that the wetted perimeter is equal to 2 times d square root of 2. So we have already expressed area and wetted perimeter in terms of d. Now we can go back to our equation for discharge using Manning's formula. So we have 1 cubic meter per second is equivalent to area, which is d squared all over n, 0.018, times r raised to 2/3. We know that r is area over the wetted perimeter. Okay, so the area is d squared over the weighted perimeter, that is 2, the square root of 2 raised to 2/3 s raised to 1/2. The slope is 0.0021 raised to 1/2. So with this, we have one unknown in the equation, and that is the depth of flow, that is 0.91 meters. So that would be the depth of flow with this. If you want to construct this particular size or section, you can um, express also, you can solve for y yung length ng sides ng triangle in terms of d. You already have an expression of y in terms of d here. Yan. Okay. Let's proceed to the next problem. It's fourth problem. A trapezoidal canal has the following flow and channel properties. Discharge is 17 cubic meters per second. Mean velocity is 80 centimeters per second. Roughness coefficient, that is 0.018. Side slopes of 4 horizontal and 3 vertical. Using the most efficient trapezoidal canal, what slope of channel is required? So we are to solve for the slope. Slope pa lang andun dito. Okay. So what slope of channel is required to produce such flow? Ano? So we're going to use the most efficient uh, most efficient section. Okay, with the following properties. No? The side slopes is for horizontal, 3 vertical. Of course, the special triangle, yung hypotenuse would be 5. Ano? So the discharge is, let's try to note yung mga given items. Discharge is 17 cubic meters per second. The velocity is 0.8 meters per second. Roughness coefficient and 0.018. Okay. Next. So from Manning's formula, Q is equal to A over N. R raised to 2/3 S raised to 1/2. Since we are solving for the slope required to produce this amount of discharge, and then we need to solve for the area flow, considering of course that the section is the most efficient section, and the hydraulic radius R in term, need to solve for the area and then the hydraulic radius R. Don't worry about the discharge because given naman yung discharge, you know. So that's it. So we need to solve these items in the equation for us to solve for the slope. Okay, so let's start with the area. So this solve for the area. So simple. Q is equal to area times velocity. Since given naman yung discharge velocity, we can solve for the area of flow. So Q then is 17 cubic meters per second times area times velocity, that is 0.8 meters per second. So we have an area of flow equivalent to 21.25 square meters. So we have solved one item in the equation. Then we also need to solve for R, considering of course that this section should be the most efficient section. No? Since we are limited with these parameters, that the side slopes is 4 horizontal and 3 vertical, um, obviously it's not half hexagon. No? But for this to be most efficient section, the top width, going back to our discussion previously, the top width, itong B should be the sum of the sides. Itong side na to. So B should be equal to 2y. Okay. And another condition is R is equal to D over 2. So we need to take note that for this to be most efficient, B should be twice of the sides, and the hydraulic radius should be D over 2. Okay, so with that, we need to solve for the depth D. So solve natin yung depth D natin. If we can solve for D, then we can solve for the hydraulic radius na, no? And we already have the area, so we can solve for the slope of the open channel. So how do you solve for D? So we know that the area of a trapezoid is equal to B plus yung lower base plus the upper base over 2 times the depth. Okay. So we need to express. So with this formula, we need to express. So alam na natin yung area, no? Alam natin yung area. Ito yun yung area natin. So gawin natin in terms of D lahat to so that we can solve for the depth. B is small letter B, or the lower base in terms of D, and then the upper base in terms of D also. Okay? And na-mention ko na kanina, the perimeter, or the upper base is equal to 2y, and then the wetted perimeter is equal to B plus 2y. Okay? So by ratio and proportion, let me adjust this para makita natin. Yan. So by ratio and proportion, we know that y ito, over D is equal to 5 over 3. So 5 over 3. Y over D is equal to 5 over 3. So that we can express Y in terms of D, so that we can express the perimeter in terms of D also. So Y is equal to 5/3 of D. Okay? So with that, B is equal to 2. So y yan, ano? Times 5/3 of D. So if y is 5/3 of D, then B is equal to twice of y, then y is equal to twice of 5/3 of D. So that B here is equal to, in terms of D, that is equal to 10/3. Of course, 10/3 of D. Ang hirap isolve. B is equal to 10/3 of D. Next, so we have expressed, ang goal natin is to express the lower and the upper bases in terms of D na, so that we can solve for the depth of flow. So tapos na itong malaging B. Next is B. So B is equal to, by inspection, sa figure natin, B minus 2x. B minus 2x. Yeah, B minus 2x. So we need to express again x in terms of D. How do we do that? We do it by, again, ratio and proportion. So x over D is equal to, x over D is equal to 4 over 3. So that x is equal to 4/3 of D. No? Now we can now express B in terms of D, since we have solved for x in terms of D. So B is equal to, yung B kanina na solve natin in terms of D, that's 10/3 of D, okay, minus 2x, twice of x in terms of D, that is 4/3 of D. Okay? So B then in terms of D, that is 2/3 of D. 2/3 of D. Okay? finally, we can now solve for the depth of flow. So what would be the depth of flow? No? So going back to our formula for areas, the area is 21.25 square meters. That is equivalent to, we have small letter b here, the lower base, which is 2/3 of d, plus yung upper base natin, which is 10/3 of d, divided by 2 times the depth. Okay, times the depth. So that we can now solve for d. So d here is 3.26 meters. Finally, we have solved for d. If we have d, then we can now solve for the hydraulic radius na t over 2. So, dalawang condition yan na for trapezoidal sections, for it to be most efficient, b, here should be 2y, which we have used kanina to solve for the value of d. And the hydraulic radius should be d over 2. So, with that, we can now solve for the slope, required slope to produce the discharge. Okay, so going back to our formula, okay, that is Q, which is 17, A over N. A is 21.25 square meters over N. N is 0.018 times R raised to 2/3. R is, where's R? R is d over 2, so that's 3.26 meters all over 2 raised to 2/3. S raised to 1/2. I hope that is legible. So, okay, this will be money. So we have one unknown in the equation, and that is S. So S, the slope required to produce the discharge, is equal to 0.00108. So this would be the slope for this particular problem. No. Yeah. Okay, so that's it. I think we still have one problem to solve. Yeah, and that would be solved in a separate video.